Hello friends, welcome to the ATC Double Cut. My name is Micah Woods and it is summertime in the Northern Hemisphere. In this episode, I want to talk about a couple of blog posts or fact sheets on the Pace Turf and ATC websites that have some good information about managing turf during hot heat stress conditions. In the first one, I will look at a post on the ATC website with the title, Catching Up on My Reading, Heat Stress Edition. This is a post that I wrote, when was it? I posted this in 2018. I think it was an article that I wrote in 2018 for the Golf Course Seminar magazine column that I write every month in Japan. And this was an especially long one. It came at the end of a summer in which Japan set a new heat record in the town of, that was in the September 2018 issue. It was the end of summer 2018, and the town of Kumagaya in Saitama Prefecture near Tokyo set a new record high temperature for the country of Japan of 41.1 degrees Celsius or 106 degrees Fahrenheit, and that temperature record was set on July 23rd. I put a chart in here and I compared the temperatures in Kumagaya in Saitama in 2018 from May 1st to September 21st. I showed those temperatures in Saitama. I showed them in Avondale, Pennsylvania, which is near Philadelphia, and I showed them in Blackville, South Carolina, which is in Barnwell County near Aiken, not far from Augusta, Georgia. And those temperatures on average, the average air temperatures in Kumagaya in Saitama Prefecture from July until September, so for the months of July and August in Kumagaya, the average temperature was almost always above 85 degrees Fahrenheit, almost always above 27 degrees Celsius. And for much of the time in July and August, the average temperature was above 30 degrees, which is about 87 degrees Fahrenheit. And that's warmer than it was in Blackville, South Carolina, which is near the Augusta area, and considerably warmer than it was in the Avondale, Philadelphia area. So it's really hot there. It's something like a tropical heat, and cool season grasses don't grow very well in a tropical climate. You don't find bent grass greens in Singapore. And of course, you can have cool season grass can grow, and it can stay alive for short periods of time. Maybe obviously 8 weeks of tropical temperatures. Yeah, it can stay alive with careful management. Maybe 10 weeks, maybe 12 weeks, maybe 14 weeks, maybe 16 weeks. I don't know exactly what that level is, but at some point, you can't have 52 weeks of the year with tropical temperatures and still have cool season grass. If you did that, you'd be in the tropics, and you don't have cool season grass growing in the tropics. So when you're growing grass in places where it is going to be experiencing heat stress, whether that's a hot 3-day stretch or whether it is months at a time, this is something that you can prepare for and manage. And in this article, I gave a list of a 12-point checklist. I said, I wrote in this blog post, I said the topic was a 12-point checklist for creeping bent grass heat stress. Most golf courses in Japan have creeping bent grass greens. In the summer of 2018 had record-setting high temperatures. I wrote about these things. So this is the 12-point list. I'll put a direct link to this post in the show notes so that you can check it out if you're interested. But I just wanted to go through this quick because I know in the Northern Hemisphere it's summer and there's a lot of people that are experiencing heat stress. So these are some things that you can consider. Number 1, raise the mowing height. Number 2, make sure there is plenty of air in the soil. Number 3, supply enough water so the grass does not suffer from drought stress. When it's really hot, and if the grass is suffering from drought stress and cannot transpire, it can overheat and die. The temperatures can be lethal. So you don't want drought stress when the grass is going through heat stress at the same time. Item number 4 on this list is grow a large plant before summer. By large plant, I mean grass has above ground plant parts and it has below ground roots and rhizomes. And I mean by large plant, I mean store a lot of carbohydrates. Store as many carbohydrates as you can in the plant before summer. And I think a fine way to do that is to use the growth potential model to apply fertilizer in proportion to the temperature. So when the temperature is ideal for grass to grow, that's when you want to be supplying fertilizer. And when the temperatures are not ideal for the grass to grow, that's when you want to be supplying less fertilizer, specifically nitrogen. If you do that, I think that's an efficient way to store a lot of carbohydrates. I can't prove that. Maybe someday I can prove that. For now, that's just something that makes a lot of sense to me. Item 5, use solid front rollers on mowers. I think this puts a little bit less leaf abrasion on the plant, and it has the effect of having a slightly higher effective mowing height. I think I didn't put anything in here about cutting with sharp mower blades, but it kind of goes, I just assume if you're doing professional turfgrass management, you should, anytime a mower goes across the turf, you want it to have sharp, well-adjusted mower blades. So that's not on this list, but that's an important thing to check. When the grass is suffering heat stress, any type of damage from mower blades that are not sharp the damage from that would be compounded. Number 6, this is quite important. If you don't have enough air movement, then it can be really helpful to use fans to move air across the turf canopy. And specifically, you want to have the speed of the air movement should be about 4 miles an hour or above. That is about, I think it's 1.7 or 1.8 meters per second. That's the type of speed of air movement that you want to have across the turf canopy in order to have a cooling effect. The grass can't recover so well if it gets damaged by disease, so you want to use preventative fungicides during periods of heat stress. Item number 8, make sure the grass is supplied with enough nutrients, especially nitrogen, potassium, and calcium. Add kelp too. Kelp is not a nutrient, but kelp is a seaweed extract, a seaweed product, and especially applying that prior to heat stress and then during the initial periods of heat stress can help the grass have a better root system. It can help the grass tolerate that heat stress more effectively. Item number 9, use plant growth regulators. If you use plant growth regulators, the grass will be, you'll have more carbohydrates stored in the plant. So you should be able to survive the heat stress periods better by having more carbohydrates in the plant, and you're not cutting off so much of the leaf and you're not removing so many of the carbohydrates. Item number 10 is remove or reduce sources of shade. Now this one's a little bit one that I might rethink now 6 years on after writing that article. I think in general, yes, we want to remove or reduce sources of shade for 2 reasons. Number 1, if you have turf growing in full sun, you will have you'll have more photosynthesis, so you'll have a healthier plant and you will have a deeper root system, a more extensive root system, and the type of plant that's going to survive the summer better. And And also, if you remove the sources of shade, it's likely that you're going to have better air movement across the area. And if you have better air movement, the turf can be cooler. So in general, I want to remove or reduce sources of shade. However, for cool season turf, if you have afternoon shade, if you have morning sunshine and afternoon shade, and that afternoon shade is not causing too many problems with air movement, but if that afternoon shade is restricting the amount of, it's restricting the direct solar radiation on the canopy and reducing some of that heat that's caused by the solar radiation, then I think it would be kind of nice to grow grass in morning sun and afternoon shade. So that's something that in general, yeah, we want to get rid of shade, but sometimes shade could help you. Item number 11, and this is specific for bent grass. I said use new bent grasses with better heat tolerance than pencross. And if you look at the new generations of creeping bent grasses, the grasses that have been released in the last 5 or 10 or 15 years, they're much better than what was released 30 years or 50 years ago. Excuse me. So as far as heat tolerance goes, if you put pencross and grow it side by side with 777, for example, and expose those grasses to heat stress, you're going to see a huge difference by the end of the summer. And item number 12, the final thing on the list, and this is for a climate like Japan where you have possibly 2 months or 2.5 months or 3 months of this type of temperature, then I said if the heat stress is a problem you can't solve, look at changing to warm season turf. So in fact, that location near Tokyo in Saitama that I showed on the chart, the temperature there is warmer than it is in Barnwell County, South Carolina. And if you look at the golf courses in Barnwell County, South Carolina, there's been a few new courses built there, and I understand that they used warm season turf on the greens. And if you go even north from there, go look at Pinehurst number 2 that just had the US Open. They have champion Ultradorf Bermuda grass on the greens. That's also a warm season turf, and that's north. Probably a little bit cooler, I would expect, than down in South Carolina. So if the heat stress is a problem you can't solve and you just know it's going to be hot during the summer, then you could look at changing to warm season turf. And I suppose if you have Poa annua greens and heat stress is a problem that you can't solve, then you might look at changing to creeping bent grass, because creeping bent grass I think is going to perform a little bit better in the heat than Poa annua would. And then if you get to the point where even creeping bent grass is struggling, then you would look at changing to warm season turf. So that is one checklist. And I wanted to share one more, which is on the PACE Turf website. This is a PACE Insights, and it is a classic one. It has a title, Heat Kills, Managing Turf Heat Stress, is by Dr. Wendy Galernter and Dr. Larry Stowell. And it has some details and a recommended management plan. This is a 4-page document. I will also put a direct link to this in the show notes. And it lists some specific temperatures. It says the canopy temperature at which irreversible turf damage occurs. The thermal death point varies from one turf variety to the next. Based on our field research and observations, we have been able to come up with some rough estimates for these values. For Poa annua, canopy temperatures of 115 degrees Fahrenheit for 2 hours or more will result in death. I think that is 49 degrees Celsius. Something like that. It's in the high 40s. For bent grass, which is a bit more heat tolerant, a canopy temperature of 120 Fahrenheit for 2 hours will result in turf death. It is important to realize that even lower canopy temperatures can cause problems if they persist for longer than 2 hours. In other words, 4 hours at a canopy temperature of 110 degrees Fahrenheit might cause the same damage as 2 hours at 115 degrees Fahrenheit. Now, we're talking about temperatures in the 40s, and that's not. I used to think that doesn't happen so much in a lot of places that are outside of the Middle East, say, or outside of the desert in Southern California or Nevada or Phoenix or Texas. There's places that are far south that do get those kind of actual air temperatures. And I always thought that the canopy temperature was pretty similar to the air temperature. But I'm coming to realize that Larry Stoll was right when he told me that actually when you don't have much air movement, the solar radiation that's hitting the surface is often going to cause things to heat up to 6, 7, 8, 9 degrees Celsius above the air temperature. So now you'll have an air temperature of 35, 36 degrees Celsius, and the canopy temperature can be 43 degrees or 44 degrees Celsius, which is getting very close for cool season grasses to that thermal death point, to the point where if the grass is going to be in that temperature range for multiple hours, it could die. And so in Fahrenheit, that is, I think, 15 degrees. Generally, you could see if you don't have enough air movement, you could have about a 15 degree spike. So I'm scrolling through this document now and checking. I think Larry wrote this exactly about fans, and he said 10 degrees Fahrenheit. Let's see. Oh no, wait a second. Maybe fans. Okay, here we go. Here's the section. So this is a really good document for anybody that wants some details about the exact temperatures. Just you may have to convert from Fahrenheit to Celsius. Fans and blowers in hot. So I'm reading from this document now. It says in hot weather areas such as Palm Springs, fans are relatively common and reliable tools for reducing turf canopy temperatures. They are particularly useful on greens with low air movement and or greens that don't drain well. In these situations, fans have been observed to decrease turf canopy temperatures by 10 degrees Fahrenheit or more when they are situated correctly. And it shows actually a picture with death of the turf in a bentgrass nursery in Palm Springs following several days where maximum temperatures were 115 Fahrenheit or more. So that's in the high 40 degrees Celsius air temperature, and there were no fans at this location on the golf course. So there's let's see. Oh, here's the section I was looking for. Okay. This is a section titled "From Bad to Worse: The Role of Damaged Turf in Escalating Heat Stress." It says, beware the presence of small damaged patches of turf on greens during hot weather. They are difficult, if not impossible, to repair. The reason? Stressed or dead turf has lost the ability to operate its stomata correctly and therefore cannot cool itself down via evaporative cooling. As a result, canopy temperatures in and around damaged turf may be significantly higher, 15 degrees Fahrenheit or more, and that's going to be 6, 7, 8 degrees Celsius than around healthy turf at the same location. So if you don't have air movement, then you won't have transpiration. And if you don't have or if you don't have turf, or if you have drought stress turf, you get these temperature spikes where the solar radiation is heating the canopy, and it can cause the canopy to rise to a lethal temperature. So the two things that you can do if you haven't if you're just dealing specifically with temperature, the two things you can do are increase air movement, or you can try syringing. Syringing is a small amount of water, not to provide water to the root system. It's just to wet the leaves or to wet the air above the leaves and cause that water to evaporate. But you need air movement for this to happen. But you just are trying to put a very small amount of water, not to provide water that the grass is going to use to take up through the root system, just to cause that water to evaporate. That's also going to cool things down for by a few degrees, but the temperature pops right back. So I've written about how I don't recommend syringing, and I don't, because permanently the solution is to increase air movement or change to a grass that can tolerate those temperatures. But if your grass is dying and you've got nothing else to do, then and you can't increase the air movement, then yes, you can cool the temperatures by putting a little bit of water, which in America that's commonly called syringing. And you can check the canopy temperatures and see how they decline. And then when they come back up again, you need to put water again. The reason why I tend not to recommend syringing is because the canopy temperature goes down for such a short time and it goes back up again so rapidly that it seems practically impossible to do syringing effectively, to really decrease the temperatures. However, if your grass is dying and otherwise is not going to survive, and you're scared that the grass is going to die, then you can go and do syringing. So this PACE Insights is quite a nice document about what you can do. It recommends a monitoring program and then certain threshold temperatures, both air temperature and canopy temperature, and when you can start implementing a heat stress management program. So I recommend both of those documents to you, and I will show, I'm going to show for those of you watching, and I'll just tell a real quick story and then I'll close this one out. I've got a background picture today of a infrared thermometer, a measurement that I made last summer of 43.2 degrees Celsius, which is well into the hundreds of degrees, well above 100 degrees Fahrenheit. And if you were growing bent grass at that temperature and it was like that hour after hour, you would be experiencing severe heat stress. Or I mean, the bent grass would be experiencing heat stress. And I suppose if you were managing it, you would be too. Now, I said earlier that I thought that it would be uncommon to have the canopy temperature spike so much more, but I think it was just because of the way I was measuring this. I'm often measuring not on research greens, but on actual golf course putting greens. But because golf courses get used during the day, I was tending to make measurements, and I've been making these measurements of soil temperature, air temperature, canopy temperature for many years. And I was always making the measurements before play, or I was making them after play. So I wasn't making the temperature measurements in the middle of the day when the sun is shining down with the full force of midday sunshine, where it really heats things up. So I would often find that the canopy temperature and the air temperature were the same, even when it was calm. And that would be in the morning, that would be in the afternoon, but I wasn't often making measurements right in the middle of the day. And I realized last summer I was sneaking onto some golf courses when it was really hot and I was making measurements in between play, or when there happened to not be any golfers there, and I was able to find, wow, these temperatures are so much higher. The canopy temperatures are so much higher than I expected. The air temperature in this case was about 7 degrees Celsius cooler, at least. It was it was 35, 36 degrees air temperature, and yet the canopy temperature was 43 degrees Celsius. So that is a checklist from the ATC website. That is a 4-page heat stress, heat kills document that is really, really useful from the Pace Turf website. I'll put links to both of those. If you are managing grass in the summertime in the Northern Hemisphere, I hope that you get through the heat stress and don't have too much grass that succumbs to these high temperatures. I will be back again soon with more turfgrass information. For now, I will sign off for ATC from Nakhon Si Thammarat, Thailand. I'm Michael Woods. Bye-bye.